Okay, all right. So let's look at question number 6. Now, question number 6 is kind of a combination of the two type of questions that we did before. The first question where we try to find out the final position when we actually flew a particular a set of tracks and distances, and you found out where your final position is with respect to initial position. That's one part of the question. The next part is when you're given a particular time and a ground speed, you can find out the departure or the distance, right? The question number 6 over here is a combination of these two questions. Okay, so let's read through this particular question. An aircraft leaves position L in latitude 37 degrees south and makes good the following tracks and ground speeds. Okay, so you take off from L, which is on 37 degrees south, and then you carry out, and then you fly the following tracks and ground speeds. Are you there with me? Can you hear me properly?
Yes.
All right. Yes. So let's. Where is L? L is on 37 degrees south. Now, before we start analyzing this particular question, it's always a good idea to see how you're flying. So, where are you flying initially? Initially, the first track from L to M is a westerly track. Correct? 270 degrees is a westerly track. So, first you're from in the southern hemisphere, you're moving first to the west, which means, think about it, you're moving somewhere in this direction towards the west. And then what are you doing? You're now traveling from M to N 180, which means southerly, which means you're turning left and you become southerly. Right? Okay. Now, and then we travel on an easterly track, 090. Again, you travel left. So basically, roughly, if you look at it, our southern hemisphere, we are traveling somewhat like this. And do you understand why I have drawn this part like this? Because southern hemisphere, it's not exactly a square, right? So, but remember, but still this angle is 90 degree. Even though it doesn't look like 90 degree, the intersection of a meridian and parallel of accurate is still 90. So you make a left turn, you are traveling westerly, left turn southerly, left turn, you're traveling easterly. Perfect. So let's kind of draw these tracks now. So it's always good to analyze the question first and see how you're traveling. So you'll have an idea of how to start and how to arrange the space for drawing. So look at southern hemisphere, right? So I'm only drawing the southern hemisphere here, just to keep the diagram simple, right? And we are on 37 degrees south, and that point is point L. Correct? Yes. So point is point L. You see why I have drawn L towards this side, towards the center and this side, because I know I'm traveling this side. If I mark L somewhere here, then I won't have enough space to draw the rest of it, right? And then you're initially making a westerly travel. Then what is the other detail given? 270, true. What is that given? 310 knots. What is that? That's the ground speed. Yes, the speed of the aircraft on the ground. Right? Now this is different from the speed of the aircraft in the air. That's called true airspeed. We'll talk about that a bit later, about what that is. But as far as we are concerned, as I told you, time, fuel consumption, it's all dependent on actual speed of the aircraft over on the ground. So I told you yesterday about tracking the shadow of the aircraft. So that speed is what is called as the ground speed. Where do you reach after traveling westerly at 310 knots? We reach point M. Right, and now we are turning left, and then we are tracking 180, which is south. Right, so let's travel southerly all the way down. And what is the ground speed from M to N? 280 knots, right? And that will take you to N, right?
Yeah.
And which means what happens when you travel from M to N? Your latitude is changing, but your longitude is not changing. But when you travel from L to M, your longitude is changing, but your latitude is still 37 south. So all those understanding will be helpful for you to do this particular problem. You reached N. Now what's the next step? From N, you're again turning left onto a track of 090 true, which is an easterly track, and your ground speed is now 250 knots. right? So we are traveling three different legs here, westerly, southerly, and then easterly with three different ground speeds, 310 knots, 280 knots, 250 knots. You can see ground speed is progressively decreasing, and this will take you to the point P, right? Perfect. Now, what is the question? P is due south of L. Now, what is the meaning of that? Let's write that down here. P is due south of L. Meridians, equator, right? Now I take a point, say P here. We have the same point, sorry, I'll take the point, yeah, P here, right? Now when I say that P is south of L or due south of L, where is L? Yeah, P is due south of L, which means P is south of L, right? So what determines south and north? So if I'm at a particular point P, how will I identify where is my north and where is my south? We use the local meridian for that. So if I track along the local meridian up, I'm going to reach my north, and if I track the same local meridian down, I will reach south. So when I say that any point is to the north of P, the point is anywhere on this meridian up. And when I say another point, say Q is south of P, Q is anywhere on the same meridian but due south. So now read the statement again. So understand the English there. P is due south of L. So L is due north of P. Correct? If P is south of L, L is north of P. So where should I mark L? L is somewhere on the same meridian but towards the north of P. Right? So we have the L already here. And they say that P is the final point P which you reached, point P which you reached is south of L. So how will I find the point P? I have to first draw the meridian passing through P, and P is going to lie somewhere on that meridian south of L, right? So if I draw the meridian passing through L, yeah, this is the meridian passing through L. Now P is south of L means P is here. Do you understand? On the same meridian south of L. If P was, so you can see L is due north of P and P is due south of L. So basically what they're trying to tell is that from N you travel with 250 knots of ground speed until you intersected your initial meridian and you stopped. So that is just to make you understand or to help you locate where point P is. That is why they have given that. But you have to understand what that statement means. So P is due south of L means L is due north of P. And that's how we draw along the same meridian. Right? Perfect. Now let's look at the rest of the question. M is reached 80 minutes after leaving P. Okay, so M is reached 80 minutes after leaving L. So you left L and you reach M after 80 minutes. So what is that?
15 minutes.
Time is 80 minutes. So you can see it is very similar to the previous type of questions. Time is given, speed is given. So we have the distance kind of there, right? Perfect. Now if you have the distance here, it is more like a departure because you're traveling along a parallel latitude. You can find Geelong, right? Now in the question, these meridians are not given, which means you can assume any of your meridian. I can assume this initial meridian as 0 degree prime meridian, 10 degree east, 10 degree anything. As long as I know what the Geelong is, you will get this meridian, right? Once you get this meridian, right? Now I know this distance here. Let's look at what it says again. M is reached 80 minutes after leaving L. P is reached 93.5 minutes after leaving N. So P is reached 93.5 minutes after leaving N. So time taken for the leg LM is 80 minutes. Time taken for the leg NP is 93.5 minutes. So by giving you time, having known the ground speed, again you can find the departure here, right? What is the advantage of finding departure here? When you find the departure here, you can also find the Geelong. How can I find the Geelong? The Geelong which you found here is exactly the same here, right? So having the departure in hand having the Geelong in hand, you can find cos of this latitude, and when you find cos inverse of that, you will get this latitude also. So you find Geelong from here, you transfer the Geelong here because they're the same, and then you find the latitude here. Now what is the question? The question is calculate the distance and time from M to N. So from M to N being your second leg, first leg, second leg, third leg. You have to find out the distance and time from M to N. So if I given the speed here, to find distance you need time. So you can see here the changes that we made. So do not round off. So you get departure as 413 nautical miles, and using that departure we found the Geelong as 8 degrees 37 minutes. Right? Now we carry forward the Geelong down to the third leg down here, where we found the departure to be 390 nautical miles, and using that departure and the same Geelong, because we can use the same Geelong because it's considered between the same two meridians, we found out the cos of latitude. And how do you find that from that? Cos inverse of 0.77. How much is that?
So how to find?
Cos inverse. Okay, so
Yeah.
cos of latitude is how much you said?
0.7.
0.7?
5.
5. Now you are stuck here and you want to find out how to find, you want to know how to find the latitude here, right? So to find the latitude, what you can do is press shift in your scientific calculator, press shift, which is on top, right? Now press cos,
Yeah.
right? So this, you'll be able to see cos inverse on screen, and then type answer.